Okay, so with this rewind on the board, number one, triangle SRT is a right triangle. So that means that one of the angles is what? 90, and the other is 35. How can you find the other angle? You can add them up and subtract it from 180, or what could you do? Just subtract it from what? 90. How come that works? Because you know the other angle already is 90. Good. And in this figure below, what is 130? What kind of angle is that? It's obtuse. It's also an exterior angle. And an exterior angle, what's the shortcut that we know? These two interior angles do what? Add up to that one, right? Why isn't it, what about this angle right here, if this were angle C? How come that one wouldn't be included? How do you know it's these two? Good, very good, David. So it's the one that's farther away because they're called what kind of angles? Blank interior, remote interior angles. Good, so these are your remote interior angles. Nice job. All right, so those are your remote interior angles. So we're going to talk about how to prove that triangles are congruent today. And what does it mean to be congruent? The same, exactly the same, right? So in a triangle, that means all the sides and all the angles are congruent if they're corresponding. And corresponding means what? What does corresponding mean? They're what? Okay, so they're in the same location, right? So for example, if I had this triangle right here, if I draw this triangle, and I say this is ABC, and I draw this triangle, and I say this is triangle DEF, which angle corresponds to D? A corresponds to D. Which side corresponds to BC? EF. Which side corresponds to AC? DF. So it's the one that's in the same location. So corresponding sides and angles are the one that are in the same location. So when we're talking about proving triangles or any shape congruent, to prove something is congruent, we need to prove that the corresponding sides and the corresponding angles are congruent also. So for instance, to prove that ABC is congruent to DEF in this diagram right here, we would need to prove that A is congruent to D, B is congruent to E, C is congruent to F, and then all the sides are congruent. And once we know that, then we can say that the two triangles are congruent. So take a look at this shape. First of all, what is this shape? It's a trapezoid. A trapezoid has how many sides? 4 sides, which makes it starts with a Q. Quadrilateral. Good, it's a quadrilateral. And 2 of the sides are what? 2 of the sides have to be parallel. So 2 of the sides have to be parallel. In this case, which ones are parallel? AD and AB and CD. AB and CD are parallel to each other because those would never touch. Which ones are parallel in QRST? TR is parallel to QS. Good. Okay, so if I asked you then to name the corresponding sides and angles of the 2 congruent trapezoids below, which one would be corresponding to angle C? What corresponds to angle C? S. Why? If you flip it, how many times are you flipping it?
Yeah. Oh, is it a rotation?
It could be a rotation. It could be a rotation by like 180 degrees. If we turn it this way, then where is Q? On the bottom right. And then this is S. And then this would be T. And this would be R. Okay, so which one corresponds to C? S. And so then, if they're congruent trapezoids, which it says that they are, that means that C and S are congruent. What else is congruent? What else could you tell me is congruent? T and A. B and R. And D, Q. And then what sides? What's congruent to S, Q? CD. All right, and we could do that for 4 more sides. We're not going to, but you get the idea. So all the 4 sides would be congruent then as well. All right, so once you know that they're congruent, why did we have to flip it like this? Could we have left it like this and figured it out? Yes? What's the point of flipping it? It makes it a lot easier, right? It helps you visualize which ones are in the same spot. Good. So Isaac said this is a rotation. It rotated 180 degrees because it turned all the way, like if it were on a clock. It started down at about the 6 o'clock, and it ended up at the 12 o'clock. Okay, so using corresponding parts of congruent triangles. So for example, right here, the given says that EFH, which is this triangle, EFH, is congruent to GFH. So these two triangles in here are congruent. And I want to find the value of x. So how could I find the value of x here? What do I know? I know they're congruent, right? What else do I know? What else do I know? H is a right angle. This angle right here is a right angle, right? So if this angle right here is a right angle, this FHG is a right angle, what else can I assume? FHE is also a right angle. Why? Because they're congruent because they make a what? They make a straight line. So this straight line right here is 180 degrees. So if this is 90, this must also be. How can I use that information to find x?
90 equals 6x minus 12.
6x minus 12. Very good. 90 equals 6x minus 12. How do I solve that? Plus 12, and you end up with 102 equals 6x, and then how do you finish it? Divided by 6. So 6 goes into 10 how many times? Once, with 4 left over. How many times does 6 go into 42? 7. So x equals 17. Okay? It says find the value of x, so that's it. X equals 17. And I know that this is 90, and I know this is 21.6. So how could I find the measurement of GFH? GFH is right here. So how could I find the measurement of GFH?
You put 90 and then you put 21 on FGH.
So
21.6.
this one is 21.6, and this one is 90. So then how do I find this one? I could add them and subtract from 180, or since I know this one's 90, I could subtract this from 90. So I'm going to do 21.6 subtracted from 90. What do I have to add to this 90 here? 0.0. Make sure you guys line those up carefully. Obviously, if you're using a calculator, you don't need to worry about lining them up, right? So the 9 becomes an 8, the 0 becomes a 9, and this becomes a 10. 10 minus 6 is 9 minus 1 is 8, and 8 minus 2 is 6. So this angle would be 68.4 degrees. What? These? Oh, I was doing short division in my head. So we put it into 10, and then there was 4 left over. All right, this one would be the same as which other angle? The other side, which would be angle EFH. EFH, good. Okay, so what I want you guys to do is 1, 2, 3, 4, 5, and then 9 and 10 at your boards. 1, 2, 3, 4, 5, read carefully. You're just saying which ones would be congruent to the questions or to the blank spaces above there. All right, go ahead. All right. Okay, so if we are going to use this in a 2-column proof, to prove that triangles are congruent, we need 3 angles and 3 sides. So the first thing we do in a 2-column proof is copy down all of our givens. So I'm going to say that my first given is that angle P and angle M are right angles. Since it tells me that those are right angles, what else could I say about them? What else can I say about them? If I know they're right angles, I know that they're 90, and if they're both 90, then that means that they're congruent. So I'm going to say right now, angle P is congruent to angle M, and that's based on definition of right angles. All right, so that's a definition of right angles because they both must be 90, like Chelsea told us, which means that they have to be congruent to each other. Okay, the next given is that R is the midpoint. I'm going to abbreviate that MP of PM. Right angles, sorry. RT? Right angles? If R is a midpoint, what does that tell me? If R is a midpoint, then what does that tell me about PR and RM? It's a straight line, okay. But if R is a midpoint, what more does that tell me about these two pieces? They must be equal. So I can say that PR is congruent to RM. Why? How do you know that? Those are sides, so they can be vertical angles. But R is the what?
Midpoint.
It's a line, and R is the midpoint of that. So that means that these two pieces have to be congruent. So the reason for this would be definition of midpoint. Good. Definition of midpoint. And then my last two givens are PQ is, well, some of these are given, some of them are conclusions that we draw from the givens. So PQ is congruent to MN, and QR is congruent to NR. So I know now that 3 sides are congruent, and I know that this angle and this angle are congruent because we already said that. Is there anything else that I can say is congruent? We already, yeah, we know MN and PQ. Tia, you said it earlier. You said the reason for it. What did you say earlier? That I said didn't work because they were lines? They're vertical what? Vertical angles. Where is the pair of vertical angles in here? The R is the vertex, right? So right here we've got a pair of vertical angles. What are those two angles? What's this one right here? PRQ. Okay, so PRQ is congruent to MRN. Why do you have to put the R in the middle? Because it's the vertex. So PRQ is congruent to, I think it's MRN. And that's because they are what kind of angles? Vertical angles. So we just say vert angles. All right, so those are vertical angles. And we still have to prove N and Q. So how can you prove that N and Q are congruent? It equals 180, and since it equals 180, if 2 of them are congruent, then the third has to be congruent. Does anyone remember the name of that theorem? We talked about it on Monday. Which angle is it? The first, the second, or the third? It's called the third angle theorem. All right, because if the first 2 are congruent, then the last one has to be. So we can say angle Q is congruent to angle N because of the third angle theorem. And now we have all the parts are congruent. So we've done enough, and now we can prove it. PQR, MNR are congruent. So triangle PQR is congruent to MNR because of, it'll be posted, because of congruent triangles. Tests we're still going to be like fill in the blanks on proofs, but yes, they're going to start showing up like that. So you won't have, you'll have like missing stuff from one side or the other for right now. That is a lot of work, right? That is a lot of stuff. It is a lot to prove that all 3 sides and all 3 angles are congruent. We are going to start talking next week about ways to do it without having to prove all 6 of those things. Because you feel like when you're looking at this, it seems like I shouldn't need to prove all of that just to prove that they're congruent, and you don't need to. And we're going to start talking about shortcuts next week, and there's several of them. There's 5 of them that we're going to talk about that will make these proofs so much easier and so much shorter. Okay? So, questions on any of the stuff that we got here? First of all, there were a lot of givens, but remember, whenever you have a given, you're going to use it for something. So when I tell you that P and M are right angles, you have to be able to say that P and M are congruent because they're right angles. So you can make conclusions based on the givens. Okay, this is just a copy of it if you didn't get to fit it all on there. And then I'm going to have you guys try this practice one at your boards.